Hi, Professor. This is Buchan. Today I'm talking about my project for the physics of the reaction. So I'm using the equation of H equals 1 over 2 gt squared. It's the basic, and I change the basic equation to other two different equations. Actually, they are same. It looks different because I use the different units. Just like the H, transfer meters to millimeters, and the time I'm using the meter second, so that in the calculating, I'm going to get a better result in my equations. And these two graphs that I just draw on the Excel. On the left, the bottom is the unit of the height, which is distance. So it's like the time will change by the distance. Distance goes up, time goes up. So is the right. The bottom unit I use the time, and it means the height will goes up while the time going up. And the material I use is my homemade cardboard. On the left side of my cardboard, it shows the distance that where people can catch. The unit of them are millimeters, and I wrote to 255 millimeters. And on the right side is the reaction time, which I already calculated to 226 millimeters. And I asked 20 volunteers of my friends, my classmates to do this experiment. And I record one of the volunteers to show you how I did the experiment.
我视频就有问题。好 ，Here's Derek, and we're going to do a reaction time experiment. Yeah, experiment.
So basically, I did it just drop the cardboard on my hand and randomly.
So
And he would just catch the
170.
and so
Second time. Are you ready?
Mm-hmm.
Okay. It's way too fast.
Okay, yeah. Too nervous.
Okay. 3, go. Here, so it's around 155.
155.
Third time. Start now. This time is like 118. Yes. First time. Start now.
I did a lot more experiment for him, but I just cut like one part of the whole videos, so I don't waste too much time. So the question was, are there a big difference between different groups of people? The answer is yes, because in my data, the people who do sports way much faster reaction time than people who don't do sports. And they also the people who have older age, who is older, have slower reaction time than people who is younger. However, I don't see any difference between the reaction of men and women. And the question two, how the reaction time will be different on the moon and in Jupiter. The question is because the gravity in the Jupiter, on the moon, and on the Earth is different. Gravity on the Earth is much bigger than on the Jupiter and on the moon, so the acceleration will be much bigger. So the cardboard, once you release your cardboard from your hand, on the Earth it will just go faster than on the other planets, such as Jupiter and Moon. So if we do this on other planets, the results of the reaction will be much faster than on Earth. And the question three, would this car stock will be suitable for a person who has extremely low reaction? For the people who have extremely low reaction, which maybe over 200 milliseconds, cannot use cardboard because the max of the reaction time in my cardboard is only 226. For the people who have extremely low reaction, we need longer cardboard to do the experiment, or the cardboard will just fall on the floor and there will be no result. And for the people who have extremely fast reaction time, actually I think they can use my cardboard to do the experiment, but for the people who have like extremely fast reaction time, like under 100 milliseconds, my cardboard will not be as accurate as the electronic devices because it's just a cardboard. It won't be as accurate as the electronic devices may have much more accurate data